record on this computer. All right. So what we're going to do here is new project. And yes, I know, right? Array list exercises. There we go. And then the last thing to make this a bit more visible is that we see that. Amazing how much that helps, right? Okay, so it doesn't look like anybody's on Zoom today, but of course I'm still recording. Array list exercises. Okay, this window. New Java class. Exercises. It doesn't really matter what you name it. And it's much easier if you put them all in the same file. So let's talk about problem 2.4, which is given two lists. Determine whether or not these lists are permutations of each other. So that is a public Boolean. So we can start out by writing public and static so that you don't have to create an object to call it. That's what static means. It's not attached to any specific object. So public static Boolean is permutation. Okay. And what we're going to do is that it's, again, with all these Booleans saying is something one thing or another, it's always good to assume one thing or another. It's easy to assume two things are permutations and then disprove that. So now the permutation takes in two lists, list A, I'll just call it capital A, and list B, and list B. You can call them whatever the heck you want. It doesn't really matter. But what they are is that they're both lists of some type that is the same type, right? They're both lists of E's, meaning they're both lists of integers, they're both lists of strings. And the reason this matters is that by putting an E here, Java knows that it can enforce that they are the same. It guarantees that they have the same object. You aren't accidentally trying to compare list of strings to list of integers. Okay, that's one of these like wonderful guardrails for you. And even better, it will automatically like just give you a compiler error. You don't even get to run the code, or you don't even get to skip to the point of running the code to find out, oh, I made a mistake. It tells you that what the mistake is and how to fix it very quickly. So what we do here now, so how do we know if two things are permutations? So let's go ahead and just, yes.
So keeping that list type E there in front of the Boolean, that doesn't mess with the return type at all?
No, that doesn't mess with the return type. This is basically telling you what by doing it with the less than greater than sign surrounding it, this is informing Java. This is that when it sees E isn't actually a class that you've built to look up. If I left it out, so if you leave this out, right, it's going to give me an error saying there's nothing. There are no lists of E's because E isn't a class. You can't resolve it, right? It has no idea what that is. Here we're saying E isn't actually a real thing. It is a placeholder name that you're going to figure out when I pass things to you. Now, as we're going to see, we can do a lot more than this because it seems really silly just to have like a single letter, right? I could make it a longer thing, but we're going to see that we can make it a lot longer. Yes.
Why did you name yours object type, or not object, but why did you name it list instead of array list?
Oh, it's just habit. First off, list is shorter, so I have to type less. But I also always like to use the more abstract type than the more specific type. Week 2 deals with array lists. Week 4 deals with linked lists, and they're both lists. So this would work for either one. That being said, you can assume right now that these are array lists. But again, it's just a force of habit that I do like I use the more abstract type so I can swap in a different type if I need to, right? This list, as written now, this works on both linked lists and array lists. If I said it was array list A and array list B, it would only work on array lists. but more importantly for teaching, it would also be longer than my screen. So, you know, it would, so it is a good question. So permutations, right? If you haven't taken your statistics classes or your combinatorics class, you may not know what the exact definition is, but permutations basically mean that it's an arrangement of items where the order matters. So if two things are permutations of each other, that means you can arrange the items into the same thing. So for instance, 1, 1, 2, 3 is a permutation, and 2, 1, 3, 1 are permutations of each other because they have the same items. And not only do they have the same items, they have the same quantity of each item. This is what makes it actually a bit of a challenging problem with with the tools you currently have, because 1, 1, 2, 3 and 1, 2, 2, 3 are not permutations of each other. They both have a different number of 1s and 2s. That's what makes it tricky, because in order to be permutations of each other, they have to have the same number of items, and you know, the same items and the same number of each item. And this is what makes it tricky. You can't just compare one item to another. You have to actually like compare the counts to each items. Okay, so how do you go about doing this? Well, there's two ways that people generally think of. The first is what I just described, which is you go through each one and you count, like how many times each item appears in each one, but then you think, wait, how do I do that? And that suddenly the loop gets really weird. We're going to go over that weird loop. It's actually not too bad of a loop. It's just weird because you iterate over the same list while iterating over the list. Sounds terrible when I say it like that. The other thing that most students students do, and this is very clever and I love it, is they think, okay, we've got two items here. So I've got two lists here. And if I want to see if two things are permutations, I should just sort them, right? So these three things are permutations of each other, because if I sort them, 1, 1, 2, 3, they become the same thing. 1, 1, 2, 3. 1, 1, 2, 3. If we sort them, they become permutations. So if we sort the items, we can just check if the lists are equal. And that's it, right? So the code kind of becomes really easy, right? Which is that I can do, let's see, a dot sort, b dot sort. It's going to crash. Don't worry. I've got to fix. There's a lot that needs to go on there. And then return a dot equals b, right? You're like thinking it's 3 lines of code. We can do that. Also, I'm going to put in one line that's going to persist into our other answer, which is one thing we can immediately do is say if a dot length, if they don't have the same size, if a dot size it is not equal to b dot size, if those two things are not equal to each other, return false. Right? If they're not equal to the same size, they can't have the same number of items and the same counts. Okay, so we get an error here because the sort function for lists apparently requires something. It says it requires a comparator. Okay, so you do a bit of Googling on Stack Overflow and you ask how to sort a list, and it tells you to use the following method. It says, oh, it's very easy. All you have to do is collections dot sort, and you take in a list A, and that works. Obviously, it doesn't, but they say it works online, right? And list B. And you're wondering, why in the world doesn't it work? Okay, let me highlight the error. And it's a bit hard to see here, but it says the required type is list T, and you provided a list E. And then it says something else over here that we're going to ignore. So you might think, okay, I'm going to ignore temporarily, but you think, okay, if I switch L, does it really care? No, it doesn't. That's not the issue. What it cares about is the line that we just skipped, which it says no instances of type T exist so that E conforms to comparable super T. What? Well, the thing is that E is anything, okay? E can be anything. it can be integers, it can be strings, but it could also be a list of scanners. And how in the world are you supposed to sort a list of scanners? You can't sort a list of scanners. There is no total ordering, as it is formally called, for a list of scanners. Sorting requires what's called a total ordering, which means that items have a specific order. Some items are smaller than others, some are bigger than others, and some are equal to each other, right? But for every item, for every possible pairing of items, there is that relationship. That's what total ordering is. So collections is saying here, we require that A and B, they aren't just list of E's, they are a list of comparables, meaning things that can be compared to each other. So the solution here is this weird thing. And this is where basically the power of generics kind of comes in. And suddenly all of our compiler errors go away. What? Okay. Yeah, I know, it's kind of crazy. So public static E extends comparable E. What this phrasing now means is that the lists of E's, these are lists of E's, A and B, both of them are lists of E's, and they are made up of E's of objects that are comparable with other E's. So what in the world is comparable? It's actually a very, very simple interface that I can just kind of pull up here with the documentation, which is again too small over here, but you can look it up online. It's an interface with one method and a lot of documentation. And what that comparable interface does, and this will become more, and you can completely ignore this until like week 7 or something, by the way, when we go over trees. But what a comparable is, that means that there's a total ordering. And anything that's comparable in Java implements the compare to method, right? Because they're interfaces. They implement this method. So strings have compare to. Integer, the class, has compare to. Doubles have compare to. So public int compare to another thing of the same type. Okay? And what it does is that returns a number. So let's go ahead and see how that works in action. So I'm going to use integers for this. So I need a integer x is equal to 5. Integer, not an int, y is equal to 10. And the reason I'm doing integers is so I can call the method. X dot compare to y. See, it's a method that works for both of them. And now if I run it, what I get when I do this is that will get a negative number. Specifically, I will get -1. Okay. So what this does is that compare to returns either a negative number, a positive number, or 0. If x is less than y, it will give us a negative number. If x is greater than y, so over here, if I switch it to 15 versus 10, x is now greater than y, it's going to give me a positive number. Specifically, in this case, it'll give me 1. And if they're equal, it will give me 0. So obviously sorting, and so now it makes sense. Sorting methods can assume that this exists for the things they're trying to sort, so that things can get sorted. Okay. Incidentally, though, notice that I didn't say it returns -1. I said it will return a negative number, which happens to be -1, or something. I said something to that effect. Anyway, yes.
So you said negative for not.
For A is less than B.
For A is less than
So if the first item is less than the second item.
got it. Positive for greater than 0 for.
So now I'm going to actually do that. So let me do this again, but this time I'm going to do it on strings. Yes.
Sorry if you answered this question already, but where does compare to live? Under which object? Or
It is under comparable. And pretty much anything that you would ever want to sort is comparable. So integer, strings, doubles, floats, anything that you would think would make sense, but primarily those things. And that was, by the way, what was going on over here when we tried to do a.sort. Notice that it said, so in the documentation, it says it's requiring a comparator. So what that is that, just as an aside, that's an object that you create if you have two objects that didn't implement the comparable interface. but you know how you want to sort them. And the comparable and the comparator is an object that says this is a special object that you call that tells you which of the two items is less than and which is the two items is bigger. Yes.
And if you couldn't use the comparable, then you have to create your own class.
Yep. You have to create your own class to do it, but that rarely comes up because in this class, it's almost always numbers or basic objects that you care about. So anyway, so if I say bird, if A is equal to bird and string B is equal to word, okay? And now we do A compared to B, we are going to get a negative number, but it's going to be a bit, we're going to get actually a bit more information here. Bird versus word gives us a negative number, but instead of being -1, it gives us -21. So in the case, now it's an interface. It just simply says it needs to return a negative number, positive number, or 0, but you can add more information than string does. In this case, what the string adds is the alphabetic distance between the two words. B and W, they're separated by 21 spaces. So it not only tells you how that one is less than the other, it tells you how far apart they are. Right? If I do weird and word, well, made up word and word. Okay, it's going to tell me -6 based off of other parameters. I'm not fully sure how it works, but the point is that it's an alphabetic distance function that lets you know how different these things are. Now, but it's the same thing. If I did B compared to A, B dot compared to A, then we get this. Okay, so that is how you fix that if you're working if you decide to sort that. So that is one way to do it. But that requires you learning a whole lot more about Java than you wanted to. Okay, and this is just the way Java does this stuff, but I mean, other programming languages have kind of these same features. So what if we wanted to actually, do this, by hand? We'll learn later about using, so if you took Python with me in 1051, then you probably learned about dictionaries in Python. This is the time when you would use dictionaries. If you did not, we will be learning about them in way more depth than you ever wanted to in about week 10. So this is not where we get to that. And we learn about why they actually do so well, because they can solve this problem in linear time. But here we're going to have to actually settle for, as we'll learn next week, quadratic time. So we've got two lists. We know that they're different, that they're the same size here. So what we have to do, so if they're the same size, that means that we can see if they're not permutations of each other by basically going through list A and making sure all the items in list A have the exact same amount of them in list B. So what we're going to do, and this is going to look a little weird, but it will make sense. For each item, I'm typing terrible today. For each item in A, what we're going to do is we're going to have an int count A is equal to 0, int count B is equal to 0, and so we don't get too confused with ourselves, I'm going to make 4 I loops here, okay? Yes? This is a for each loop, okay, in Java. Just like the for loop in Python, if you've taken Python, if you haven't, this will look a bit, if you took C instead, this looks a bit weird. But what this does is that it automatically iterates through the item, through all the items. This is great if you want to just simply go through each item and don't care about the indexes, which I don't in this case. It's terrible if you care about the indexes because you don't have access to the index anymore, right? So it's very useful here. You will have to use them, and again, around week 10, when you have to do sets which have no index. So, but for each item A, what we're going to do is I'm going to now do 2 inner for loops, and I'm just going to do them as 4 I loops so it doesn't look too weird. So for I, int I is equal to 0, I is less than A dot size. This is the most annoying thing in Java, by the way, which is that they decide in their infinite wisdom to figure out how big things are. It's dot length, no parentheses for arrays, dot length with parentheses for strings, and dot size with parentheses for collections. So, which is what we're working with in data structure. So it's very annoying compared to other programming languages that just generally have one function. But anyway, so for each item there, we're going to say what we're going to do is we're going to say if a dot get the item at I, if that is dot equal to the item that we're looking at. So for each item in A, we're going to look at every item in A, every other item in A, including ourselves, because we're not going to bother skipping over ourselves. If it's equal to the item we're looking for, count A plus plus, right? Increment our count. Then we just simply copy, paste, and switch all the A's to B's, right? So now we go through B and look at all the items in B. And if it's the item we're looking for, increment B's count. So for each item, so like for each one, we're going to go through and, or so for each number one, we're going to go through and count the number of ones in A, count the number of ones in B. Then what we're going to do in the next step of loop is go through and count the number of twos and see if two is the next item in A, we're going to count the number of twos in A, then count the number of twos in B. Yes.
When you write dot equals item, isn't B dot get I comparing it with the items from A?
Yes, that's fine.
Okay.
Because we're checking if every item in A exists in B. We're trying to see what counts for items in A. And we can do this because we have verified if the reason is, and you'll have to jump through some logical steps to get there, but the reason is because we've checked the sizes and made sure the sizes are the same. This works because we know the sizes are the same. And so anyway, once we've counted up all the items, if count A is not equal, if the counts differ, count A is and count B differ, return false. They can't possibly be permutations of each other. So loop stops. So a lot of typing and a bit of copying and pasting, but that is the answer. And yes, it's quite large. Don't worry, because what I'll do is I'll just copy this and paste it and drop it into Discord for y'all. Okay. So let me go ahead. I'd rather you pay attention to what I'm saying rather than try to frantically copy things down. There you go. It's in Discord now and the 2168 channel. So, and if you're not in Discord, well, this is a recording of it. So, and you can always join later, or just email me for the code if you need it. So, but this is your 2.4. Yes.
So this would be considered like brute force in a way.
Yeah. I mean, you're just doing pairwise comparisons here.
Sorry.
There's not, and so this is kind of annoying to do, but it is also like, there isn't a pretty way to do it, unfortunately, other than sorting it. But the sorting it, well, the advantage here is that this works on things that aren't comparable too. At this point, I could remove the comparable and it still works because I don't need to compare things anymore. Comparing is only useful if I'm sorting things. Here, though, if I just care if things are equal or not, they don't need to be comparable. So this was by far the hardest one in your second problem set. Don't worry if that one didn't make any sense to you or made only partial sense to you. The point being, if you look at the code, it will make more sense as you do this. It's a bit, again, like I said, this one's a bit rough, but that's why I wanted to go over it in class. All right, so with that, I'm going to go around and give individual help to anybody who needs it on this one. For demos for lab 1, I will take them probably after class. My priority right now is handling questions, so problem solving. Make sense? All right. Yes.
Just a quick question. You can demo even after the due date, like
Oh yeah, you can. You do not need to demo by the due date. It's turn in, and then you have like 2 weeks or so after the due date. And if you need more than 2 weeks to demo for some reason, just let me know. The main thing with the limit to where you have to demo is so that I don't have any bad actors. People acting in bad faith. Yes. Because 40 manually is if you're, here we're manually, here we're manually counting. And so, so for line 20 through 27, we are manually counting, we don't need to pull that. 40 manually, we want to skip all manually. And kind of clever. That's where my industry is. Yes.
Okay.
Yeah, the reason being is that I had, this is the way without that. Because I know they're the same amount, so if they don't have the same, if they don't have the same, then when you then they call that, then one of the counts somewhere else.
Yeah.
It's a bit of a logical.
You wanted to, well, technically, you already know how to assign something a person is something.
Yeah.
But he was gonna be, I think Carolina was to compare it, then this would be.
These, so basically, these are whatever. But if that's pretty inherent to do over 16 of the text.
He's counting the number of. So like, let's say our A
All we need is
list
a pair.
and our B list is 2, 3. So what ends up happening is, A count is like, counted 1 time, counted 2 1 time, counted 3 1 time. Yeah, so you do, that, so that's what I was wondering. But I don't know where, how in the code it does that, but what I ended up, like, I find out is like, thinking, this is what he's doing. He's technically saying, I didn't count 1. Well, so I know the number of difference is somewhere. But you're right, it would be technically 3, 3.
When you say, and just compare that, I thought. Yeah. Pretty much.
Here, these are ones. You know, what I mean, I have available. And you can sign up that.
I think that last time.
Then I go over here.
Let's try to write.
Then.
But you should ask him, yeah. But like, so let's say. Well, we definitely need to understand what. So A dot get I, let's say, or I, so A dot get 0.
Go ahead.
Let's say that.
So the way that
It's like really awesome. But then. A is 1, 2, 3, B is 3, 1, 2. Technically, they should be.
So.
B dot get I, and then we're saying dot equals, right? We compare like the item in. I think so, that'll be true.
Okay, some of them.
That'll be true. This A, count A.
But it's-
Now let's do the 4 list. So B dot get.
You don't have to worry about those.
That's gonna be 3. Because I is there. 3, and 3 would be equals to. Oh, this is what it's doing. The outer 4 loops, it goes through all the items of A. So what he does it, so he compares three with one. Right? Not even. He compares three with one again. You see the inner form right now, it only, oh, no, I flipped it.
So he'll rent it, so.
He'll do- Yeah, yep,
Or he'll-
yep. And if they're not the same number, so let's say three equals one, it's not, one equals one, or one does equal one. So count, count B plus plus. Okay, now we go to the next item. Which is, it's three equals to one. Back in I. And then we get one equals to one. Two. And then we do, two compared to
Or three.
our, yeah,
Three, start.
yeah, three compared to two. So it goes through until the last I compared to three. And three. Yeah, and then he says that's the same number, right? It's actually better to see on paper. You still don't
Yeah, I
know.
did, that's, yeah, we not figure that out. So, but technically speaking, you say it's.
The I, the I would, so
Or
if you,
count, sorry, count better, get the five. There's five items.
there's, so let's say, let's say there are more items each.
Three is,
Let's say,
three sound, so I didn't put anybody.
there's more items. For this to be true, for them to be considered the first stage of each other, they both have to get to the same number. Count A and count B must be equal. And if they're not equal, you return false.
Yeah, yeah.
And if the count is not equal, that means somewhere this number was present and in that list it wasn't there. Yeah, that's the only, because let's say,
So basically the side.
let's say it's one. Have a zero. We will go through, zero is never gonna be count. So it'll be comparing zero to three, so this would be A dot count. And this would be B dot.
And then it returns.
And then it's like, oh,
So basically the, I guess the thing I was trying to say is like.
yeah.
Only one that had. We're starting with A. So all we need to do is see like the size of A, if not B equals the size of A. Like you don't, do you even need this?
Oh, good. I see what you're saying. Wait, let me think. No, let me think.
If they hit the ball.
Yeah, because we know.
Yeah. Kinda like if it matches, you gotta reach the total number of items.
Yeah.
All it needs to do is.
Yeah, yeah, you're right. If you know it's gonna equal to each other. Yeah, there's no point in that. Wait, run, yeah, comment that out and do if A dot size. If A dot size not equal. But I feel like we might have a court, like some case where this, we should ask. But yeah, run it, like.
I need.
Oh.
So, but if your five is not.
I'll shoot you with strings because this is fine anyway.
You know, so here you get the item, so yeah, I put in the same. Everything will. We don't know, so. Now he's actually.
I'm just thinking why you would do that, like, to get something that you don't know, but.
So Twitch is always in full of everything. And then over here, we see the.
Turns around like.
Okay, yeah, that's. Actually got all, and I didn't change it. So like, I can explain. So like, it's nice to be, now he's no. Decide if things are possible. I would make the analysis not but like, I don't see there. Like, occasionally, like, there's like a line, bushes. My God. And maybe if it would be like. Because right now, what I think, any non-word character followed by at least one. Be like kind of literal S. Okay. Here though, what.
Yeah, I don't know. Essentially, it does like. I don't think it's a lot.
Yeah, so here what you wanna do, honestly, it is easier for you to split, just do flashes as plus, okay? So then what you wanna do is, rather than like just automatically all four, string, word, and array. Now go through.
I get the demo,
And stand.
I like emailed and I did it.
Then you can just-
I want to do the research. I was like, oh, it's like taking that really.
Is word is equal to word dot replace. I don't know. You old character, new character. Probably not.
You just went in there and didn't listen.
In that case, we need to use more powerful ones. Old character. Here, there's no targeting and placement.
Yeah.
We're gonna leave the placement blank. And then you can do it like this. So for regular expressions, though, what you can't do is do this, because the regular expressions just means any period is short for any character. So for actual period.
Okay. So did you do that for your live? Yeah, I did that. Where's the?
In fact, I think. Oh, okay.
Oh, too bad.
Wait. Yeah, replace all of it though.
Okay.
Otherwise, this way it would just.
So you have a question about, I use the first. Of count A plus plus, when it's like you already know eight outside, couldn't you just compare if it's like eight outside is not equal to count? I think we should skip that.
No, you can't.
Why?
So count, because you have to count the number of times each item occurs in A.
We are, okay.
Each item, so for each item in A, you gotta count the number of times. it occurs in A.
Wouldn't that end up equaling to the size of it?
No, the count for each item, you count the number of times that item occurs in A, and then the number of times that specific item occurs in B.
Okay,
Then that, and so the count is inside that four. So it means that resets every time we go to a different item.
okay.
That also means that some, we have made some processes by counting the same item again and again. They get it right, kind of certain effects.
Yeah, I was actually just trying it to like compare it every single time.
Every single- yeah.
Yes. Proper,
Yeah, yeah.
Okay, all right, that was about fine, yeah, first line back there. So I won't say with that one. But but anyway, go down to, the one that's online, yeah, these are small. Okay. That will work. That won't necessarily work if you've got like some, weird. Yeah, you test it on, test it on things that. Oh, with the plug, that will work, okay. And then here. It will. It will look like a. And you should have, and what should happen is that you'll miss a five. Okay?
I'm gonna try to follow something the same.
Mhm.
I just didn't. I just. And here's.
Like by the end of this programming.
It's possible I made a complete and utter mistake, so. I should have. So yeah, you don't find, they're the same, and the item.
Let's do the quick.
If count A is not equal to count B.
So this module.
Okay. Whatever anything else is.
Yeah.
Oh, yeah, there you go.
Yeah, that's what we.
Yeah, it's true. Oh, yep, let me go ahead and fix that on the code on my submitted. Yeah, I forgot to change the code I submitted, so give me 1 sec. Nice catch, by the way. That's the issue when you try to work on 2 iterations. Sometimes you forget to comment out one of the lines. Edit.
Yeah.
Return true. There we go. So that should be a return true. There we go. Stop recording.